Okay, in the last video we talked about how to rationalize the denominator if there's a monomial in the bottom. So we said, well, you either just simplify the radical to start with and it nicely simplifies all the way out to a whole number. Excellent. Or if there's a radical that's stuck in the denominator and it won't simplify to a whole number, then we multiply that radical by itself. And when we do that, it allows us to simplify all the way to a rational number in the denominator. Okay. Today, in this video, we're going to talk about what to do if there's a binomial in the bottom. Okay. If there's a binomial with a square root in the bottom, it doesn't matter if there's one square root or two square roots involved. If there's a square root anywhere in your binomial, what you want to do is you want to multiply it also by a binomial. Okay, and we choose a very specific binomial, in which case we know the middle term will cancel out and get rid of those. It resembles the difference of squares that we did. We use what we call the conjugate. So there's this word up here, conjugate. It says, what is a conjugate? I'm just going to show you a few examples. A conjugate, if I have something like 2 plus the square root of 5, and I want to find its conjugate is going to be the same binomial with the same terms, but we negate or do the opposite sign in the middle. So 2 plus the square root of 5, its conjugate would be 2 minus the square root of 5. If I had 3 square root of 2 plus 7, its conjugate would be 3 square root of 2 minus 7. Okay. If I had 4 square root of 2 plus this, let's do a minus. So if this one was subtraction, then its conjugate would be addition. But again, those binomials look identical with an opposite sign in the middle. So when I come down here and I see that I have a binomial of 1 plus the square root of 6, then I automatically, I'm going to zoom just a little bit, know that I want to multiply it by its conjugate binomial. So 1 minus the square root of 6, and I'll show you why. And then just remember, anything you multiply on the bottom has to also multiply on the top, so you want to multiply both of those. So over here, we're going to distribute this on the top, so 2 times 1 is going to give me 2. 2 times the square root of, negative square root of 6 would be negative 2 square root of 6. So you just distribute on the top. Then on the bottom, we need to FOIL. So we do 1 times 1 is 1. 1 times the negative square root 6 is negative 1 square root 6, or just negative square root of 6. Then the square root of 6 times 1 is positive square root of 6, and square root of 6 times negative square root of 6 is negative square root of 36. So when I'm simplifying on the bottom, what I want you to notice is that your square roots will all go away. So I'm going to rewrite the top because we kind of simplified that already. Sometimes you'll have to simplify that a little bit more, but that one looks good. If you notice on the bottom, you have a 1 here in front. You then have a negative root 6 and a positive root 6. Because we chose the conjugate, those two middle terms will always cancel out. That's why it's important that we create a binomial that's identical but with a different sign. It creates one positive inside term and one negative that will cancel out or add to 0. And then down here at the end, right, you have the square root of 36, which is that's a negative 6. So on the bottom, you really have 1 minus 6, which is a negative 5. Now, it's mathematical etiquette probably not to leave a negative in the bottom, but for now, I'm not worried about it. We just want to make sure that we know how to rationalize that denominator. Okay, let's jump down and look at a couple other examples. So doing this same thing. So number 10. Again, I recognize there's a binomial in the bottom, and I need to get rid of that radical, so I just want to multiply. And I like to put parentheses around it to remind myself that I need to FOIL. So I'm going to multiply it by its conjugate. So remember, the conjugate is the same binomial, opposite sign. Anything we multiply to the bottom, we also multiply to the top. So let's go ahead and distribute on the top. We've got 2 square root of 3 times 4. So that would be equal to 8 square root of 3. 2 square root of 3 times the square root of 5 is 2 square root of 15. that's a plus sign. On the bottom, we're foiling 4 times 4, 16. 4 square root of 5. Negative root 5 times 4 is negative 4 square root of 5. And then negative square root of 5 times square root of 5. Negative square root of 25. It's getting close over there. Okay, so again, we kind of lucked out on the top. If the radicals on the top simplify, you do need to simplify them as much as possible. And then on the bottom, again, we have the 16 here on the left. These two middle terms cancel. And then the square root of 25 is just 5. So essentially you've got 16 minus 5, which is 11. Now before I'm done, I would ask the question, do the coefficients divide or have a common factor? In this case, we've got an 8, a 2, and an 11. So these ones don't, so we are finished at this point. Okay, and that's the extent. That's what we do. If there is ever a binomial in the bottom, we want to multiply it by its conjugate. That allows this bottom to simplify to a whole number. And then again, if you can simplify the top, just simplify, simplify, simplify until you're all the way done.